So let's try to go for how we will write the expression of velocity, acceleration, and how we can use all this expression to different types of problem. Okay, so let's try to go for the motion in 2 dimension. So obviously, if we have Cartesian coordinate system, suppose this is my x and this is my y, and any particle is moving on this particular path, and its coordinate in xy coordinate or in Cartesian coordinate is given by a position vector, and this position vector is what? Xi plus yj, isn't it? And what is direction of this particular position vector? I cap and j cap. These are two unit vector along x direction and along j direction. So this is in a Cartesian coordinate. And if you want to calculate the velocity, then the velocity is all about r dot, and this will be x dot I cap plus y dot j cap. This I cap and j cap are the unit vector, and which is not changing with the time. That every time it has same I cap, every time it has same j cap. So this is one of the very fundamental thing you have to understand. And similarly, we can, and this is my velocity vector, and similarly we can write the acceleration, and when we are going to write the acceleration, then this will be second derivative, and this is our x double dot I cap plus y double dot j cap. So in general, if we are using the Cartesian coordinate, we assume our x direction as one, our coordinate in one direction, and y is the another direction. And these two are orthogonal in nature. That means these two are perpendicular in nature. But every problem cannot be solved into Cartesian coordinate, especially when there are angular variation of a particle is there. So if there are angular variation of a particle, then obviously the best coordinate system is nothing but the polar coordinate. So when we will go for the polar coordinate, let's try to see what will be the basic fundamental calculation behind the polar coordinate. So if we are talking about polar coordinate, that means we are talking about two direction. One is radial direction and another is tangential direction. And this is my r vector, and this r vector will make angle theta in anti-clockwise direction, something like this. This r vector will make angle theta with x-axis. So this angle is also theta. ये angle भी क्या होगा? Theta होगा. So what is our first duty? I just want to write this r vector in a basis of I and j cap. R vector को हमें I और j cap के basis में लिखना है. So how we will write it? Very simple. We will take a projection of r cap, and this r cap is a unit vector along r direction. What is r direction? This is moving away from origin or towards the origin. And what is theta? It will just tell you how you are changing this angle with the x-axis, something like this. So suppose you are doing the spiral motion, something this type of motion, suppose this kind of motion is there, then it is very difficult to solve this type of problem in a Cartesian coordinate. Yes, mathematically you can solve it, but it is not very efficient method. So what we have to do? We have to go for a new coordinate system. So now what will be my r cap? My r cap is that, बताओ तो r cap क्या होगा? What is my r cap? Anyone? r cap को हमें I और j के बेसिस में लिखना है. कैसे लिखोगे जरा बताओ? बताओ?
सर प्रोजेक्शन लेकर के.
हाँ, तो क्या होगा बताओ?
cos theta I cap.
Very good. Cos theta I cap plus sin theta
J
जे कैप, है ना? cos theta I cap plus sin theta j cap. And this is unit vector, and you can see cos square theta plus sin square theta is equal to 1. So magnitude is 1. What is your theta cap? Anyone? बताइए, what will be your theta cap?
minus sin theta I cap plus cos theta j cap.
Very good. So that is minus sin theta I cap plus cos theta j cap. You can see this is one type of transformation. And this is r cap, this is theta cap. And if I want to write something like in a matrix form, cos theta, sin theta, minus sin theta, cos theta, and this will be I and j cap. Isn't it? And what is this matrix? इस matrix को क्या कहते हो?
transformation matrix.
Rotation matrix.
Rotational
Sir,
matrix. This is very famously known as what? Rotational matrix.
सर थीटा कैप कैसे लिखा प्लीज एक बार बता दीजिए।
चलो आप खुद बताओ। थीटा कैप को आप इस डायरेक्शन में ले जाओ, इसका एक डायरेक्शन क्या होगा? इधर होगा, दूसरा डायरेक्शन इधर होगा, है ना?
यस सर।
चलो इस जे के डायरेक्शन में ये एंगल क्या होगा? 90 माइनस थीटा।
यस सर।
ये एंगल क्या होगा ये बताओ? थीटा।
थीटा।
ठीक है, तो इसका कंपोनेंट इस डायरेक्शन में क्या होगा? जे कॉस थीटा।
यस सर, कॉस थीटा।
और दूसरा वाला कंपोनेंट इस डायरेक्शन में आएगा
साइन थीटा।
माइनस साइन थीटा, है ना?
साइन थीटा सर।
माइनस साइन थीटा। ठीक है,
थैंक यू सर।
वेरी गुड। सो एंड दिस इज व्हाट? रोटेशनल मैट्रिक्स। रोटेशन अबाउट व्हिच एक्सिस? किस एक्सिस के अबाउट ये मैट्रिक्स है?
Z
Z-axis. This is something like rotation about Z-axis. Okay. So this is the motion is in XY plane. So rotation is about Z-axis, and you can have this particular rotational matrix. Okay, that is different issue. And this is, you can also check. This is something like orthogonal matrix, isn't it? कैसा matrix है ये? What is orthogonal matrix? You can just check. What is orthogonal matrix? A inverse or R inverse is equal to R. Something like this, isn't it? आप check करने की कोशिश करना. Anyway, so this is my R cap and this is my theta cap. Now, is that R cap and theta cap is independent of time or dependent of time? अगर मैं आपसे पूछूं what will happen dr cap upon dt, is that this will be 0 or it has some value?
It has some value.
It has some value. Why it has some value? Because theta is changing with every time, isn't it? Theta is a dynamical variable, so it is changing, and you can see, we will discuss it later. First, we will do it mathematically such that you will get a lot of confidence. So if we have dr cap upon dt, what is this value? Minus sine theta, theta dot I cap plus cos theta, theta dot j cap. होगा ना?
Yes, sir.
Okay, and I can take theta dot common. What will happen? Minus sine theta I cap and j cap.
Theta dot theta cap.
Very good. So you have, I can take minus sine theta I cap plus cos theta j cap, and you can take theta dot common. What is this value?
Theta cap.
Theta cap. So rate of change of r cap with respect to time, in which direction? That is in theta cap direction, isn't it? r cap का जो rate of change है वो basically किस direction में मिल रहा है आपको? That will be in theta cap, and that theta dot is angular velocity. And similarly, we can also get d theta cap upon dt. What will be this value? Minus cos theta, theta dot I cap, and again cos theta को differentiate करेंगे तो क्या मिलेगा? Minus sin theta, theta dot j cap. Okay. And again you can see d theta cap upon dt is equal to minus theta dot, and you have cos theta I cap plus sin theta j cap, isn't it? And d theta cap upon dt is nothing but minus theta dot r cap. So this is two very fundamental equation for polar coordinate. And due to this equation, now look at, this is very interesting. D theta cap upon dt. Rate of change of d theta cap upon dt in which direction?
Opposite to radial direction.
Opposite to radial direction. And you can, I will just give you the intuition and I will also prove that when something is rotating, there is one force is acting towards r cap direction, isn't it? If something is rotating, is that any force which is working into the towards the radial direction? Suppose
Yes,
it is
sir.
rotating. Is that any force which is working towards the radial direction?
Yes, sir.
What is that force?
Centrifugal force.
Centrifugal force. So what is the source of centrifugal force? How you will get centrifugal force?
Due to rotation.
Due to rotation. Unless until you don't have changing r cap, changing theta cap, or you will not have centrifugal force. So suppose something is rotating, then every time your theta cap is going to change, isn't it? Suppose something is doing the circular motion, then what will happen? Every time your theta cap is going to change. This is tangential velocity, isn't it?
Yes, sir.
And due to this tangential velocity, hence your direction is going to change. What will be the net effect towards the radial direction? Look at this thing very carefully, isn't it?
Yes, sir.
And you will also surprise, this will also give you one net effect that is very famously known as what? Coriolis force. We will discuss it when we will go for rotational frame of reference. But right now, you can see these two mother equation which will help you to calculate all the velocity and acceleration of a particle. And now let's try to go for writing a position vector. So let's try to go for writing the position vector. So when we want to write the position vector R, what I can do? I can write x is equal to r cos theta I cap plus y is equal to r sin theta j cap. What is r here? What is r here? This r. This r is vector. What is this r?
Under root x square plus y.
Exactly. This is magnitude. Very good. So this r is nothing but magnitude, and which will be root under x square plus y square. And what is theta? Tan inverse y upon x. Isn't it? And now, if you want to write, now here we are writing this position vector in a I and j cap. And look at what is going to happen. If I am taking r vector, I can take r common, and this is cos theta I cap plus sin theta j cap. And what is cos theta I cap and sin theta j cap?
R cap.
R cap. It's a awesome thing. It's a very, very interesting thing. R vector in a polar coordinate is magnitude and only one direction. Look at here. Now, when you are going into the position vector in a Cartesian coordinate, then how many direction you needed to define your particular position vector?
2.
2 there.
No, 4. I, J, you have to define I and J as well as X as well as Y.
Yes,
2
sir.
direction and 2 magnitude, isn't it?
Yes, sir.
But look at when you are defining your position vector in a polar coordinate, what you need?
1 magnitude and 1
One
direction.
magnitude and 1 direction, isn't it?
Yes, sir.
So it is much better that we should work the same thing in a less and lesser variable. And now you can see, now your question will be a very natural question. Sir, where is theta? You are just writing this particular R. Where is theta? Are you getting my point or not? आप यहां पर R लिख रहे हो. Where is theta? Now look at how theta will come into picture. So this is my position vector. What is this particular R? Is the magnitude. And what is this particular R cap? Is the
Direction.
radial direction. So this is my position vector. So if we are writing this particular position vector, what we will do? We will just go and write the different. We will just try to go for velocity and acceleration in a polar coordinate system. यहां तक कुछ पूछना है तो पूछिए, otherwise I have to clean my board. Anyone? यहां तक क्लियर है ना?
सर थीटा
हाँ।
डॉट चेंज इन एंगल है तो उसकी वैल्यू नेगेटिव हो जाएगी तो भी हो सकती है, तो डी थीटा कैप ओवर डी की वैल्यू पॉजिटिव आ जाएगी, पॉजिटिव आर्क है तो वो
कौन सा?
आउटवर्ड फोर्स, ये जो इक्वेशन सामने लिखे हैं
ये
डी थीटा कैप उसके नीचे वाला इक्वेशन
ये
ब्रैकेट, हाँ
नहीं,
उसमें
आप देख लो.
थीटा कैप की वैल्यू 2 एंगल्स पे डिपेंड कर रही है.
आप
थीटा
देखो तो
डॉट,
यहां पर
हाँ,
देखो ना, डी थीटा
Yes.
कैप अपॉन डी टी माइनस कॉस थीटा थीटा डॉट आई कैप.
यस
इसको डिफरेंशिएट करो
सर,
और कॉस थीटा को डिफरेंशिएट करो माइनस साइन थीटा थीटा डॉट.
जी
माइनस थीटा डॉट को कॉमन ले लिया,
जी
कॉस थीटा आई कैप प्लस साइन थीटा जे कैप.
जी सर,
एंड व्हाट इज कॉस थीटा आई कैप एंड साइन थीटा जे कैप? इज आर कैप
आर्क,
एंड माइनस साइन विल बी देयर. ठीक है.
ठीक है,
नेगेटिव साइन का कुछ सिग्निफिकेंस है, आपको दिखाई देगा, डोंट वरी, है ना? एंड इट इज वेरी नेचुरल.
जी सर.
ओके. चलो. Okay. So let's try to derive the velocity and acceleration, and then we will do lot of analysis. Okay. So we have a very nice situation. Obviously, I have to give x and y, then only we can define r. So this is my r vector, this is my theta, this will be my r cap, and this will be my theta cap. And we have mother equation dr cap upon dt is equal to what? Theta dot
Theta cap.
theta cap. And second is d theta cap upon dt is equal to minus
Minus theta dot
theta
r
dot
cap.
r cap. पिछले बार जैम के एग्जाम में तो जस्ट फॉर्मूला ही पूछ दिया था ये, है ना? सो एंड व्हाट इज माय r वेक्टर इन पोलर कोऑर्डिनेट? r cap. क्लियर है ये? नाउ लेट्स ट्राई टू गो फॉर वेलोसिटी. What will be velocity? Obviously, definition is not going to change, but yes, expression is going to change. So v is equal to dr upon dt. What will happen to this one? क्या होगा जरा बताइए? we have to go for dr upon dt r cap, because we have to differentiate it completely, plus r dr cap upon dt. And you can see what is dr upon dt. This is very famous r dot, that is known as radial velocity. And what will be dr cap upon dt?
Theta dot
Theta dot theta cap. And what we have r dot r cap plus r theta dot theta cap. And now this is nothing but radial velocity plus, and you can write something like this, Vr r cap plus V theta theta cap. And what is your Vr? Vr is basically r dot identified as radial velocity. And what about V theta? This is r theta dot. Please, V theta is not theta dot. V theta is something like r theta dot. And this is nothing but tangential velocity. And what is your theta dot? Angular velocity, isn't it? Okay. And what is direction of theta dot?
Z cap.
Z cap direction. Direction of theta dot is what? Z cap. We will discuss it later. What is meaning of that? So in the plane, if you are working into the polar coordinate, either you can go away from radial direction. So this will be r dot, or you can turn to the tangential direction, tangent to the curve in theta cap direction, and that value is r theta dot. This value is nothing but what? R theta dot. Okay? And this is your radial velocity and this is your tangential velocity. So if you want to move away from the origin, so this will be just go away from the origin, and another is just try to sweep the angle. Just try to go for this particular angle. So theta, r theta dot is just try to make it change this particular angle for the given value of r. And this is two particular thing. But the most exciting is all about, and now you can see, in fact, we are not using theta cap in a position vector, but we are getting the effect of theta dot in a velocity. Actually, the change in angle is inherently given into r cap. You look at here, isn't it?
Yes, sir.
So if you want to see the whole dynamical thing, the dynamical variable, here r cap is actually, if you are changing r cap with the time, it will give you some effect into theta cap. And so why it is more than enough that you can define your position vector only in radial direction as well as radial magnitude. Obviously, if I am talking about magnitude, that should be always radial. So it is very efficient. And now let's try to go for basically acceleration. So what is your acceleration? What is acceleration? Acceleration is nothing but dv upon dt. And now we have to go for this particular differentiating this particular thing. So what will happen? R double dot r cap r dot dr cap upon dt plus dr upon dt theta dot theta cap plus r d theta dot upon dt theta cap plus r theta dot theta cap upon dt. ठीक लिखा हूं मैं? Everybody?
Yes, sir.
Okay. Now, what you will do? You will just write r double dot r cap plus r dot. What is dr cap upon dt? Theta dot
Theta cap.
theta cap, isn't it? And this will be again dr upon dt r dot theta cap plus what is this particular value? R d square theta upon dt square in theta cap direction plus what will be d theta cap upon dt?
minus theta
Minus
dot
theta
r
dot
cap.
r cap.
Exactly, that is minus r theta dot square in which direction? R cap direction, isn't it? आप प्लीज इसे डिराइव जरूर करोगे आज की क्लास खत्म होने के बाद, है ना? Okay, now this is my r cap. Sorry, this is my acceleration. Now what we will do? We will just collect the radial part and we will collect the tangential part. यहाँ तक clear है ना? So I will use this space. Okay, I think this is also not needed. चलिए. So what is my acceleration? My acceleration is r double dot minus, can I take this one? R theta dot square in which direction? R cap direction plus what will be next one? You have r theta double dot, I can write it theta double dot plus this term and this term is exactly same, and you have 2 r dot theta dot, and this is in theta cap direction. Everyone is comfortable?
Yes.
sir.
And now you have two direction of acceleration. One is in the radial direction. So A is written as AR r cap plus A theta theta cap. And now look at what is your AR? AR is equal to r double dot minus r theta dot square. Are you people comfortable?
Yes.
Yes, sir.
AR is nothing but r double dot minus r theta dot square. This is your acceleration. R double dot is not your radial acceleration. What is your radial acceleration? Is r double dot minus r theta dot square. This is your radial acceleration. So you have one acceleration in this direction, which is popularly known as AR. And what about A theta? A theta is nothing but r theta double dot plus 2 r dot theta dot. And now you will just try to see. यहाँ तक clear है ना? How you will write the Newton's law of motion? Now in this case, if you want to solve the Newton's law of motion, then you will resolve the force in a r cap direction and you will resolve the force in a theta cap direction. You will just forget your x and y. Just resolve it in a r cap direction as well as in theta cap direction. And you can write your Newton's law of motion that Fr is equal to m AR, and which will equal to m r double dot minus r theta dot square. And you can see this term, if we are just going for this particular term, minus m r theta dot square is nothing but identified as what? Centripetal force, isn't it? This thing is nothing but what? Centripetal force, and it come automatically. So if you are using this particular polar coordinate, the centripetal force will come automatically in the AR direction. And what about F theta? Your F theta is equal to M A theta, and that will be M R theta double dot plus 2 R dot theta dot. So this is your F theta. So you will resolve each and everything in direction of F theta and FR, and you can solve it simultaneously and you can get the solution. So अब आप यहां पर R डबल डॉट से आपका काम नहीं चलेगा या थीटा डबल डॉट से काम नहीं चलेगा. You have to use AR, expression of AR and expression of A theta. This is very interesting. And now let us try to go for a one particular expression. Suppose the particle has mass m and which is rotating at r radius. What will be angular momentum? What will be angular momentum?
R cross P.
R cross P, isn't it?
Yes, sir.
So angular momentum L is nothing. R cross P. And R can be written as R into R vector. Okay. And P can be written as R dot R cap plus R theta dot theta cap M into V, isn't it?
Yes, sir.
So what will be R cap cross R cap? 0?
0.
Okay. So you have angular momentum, and that angular momentum is M R square theta dot R cap cross theta cap. Yes?
Yes, sir.
And what is R cap cross theta cap?
Z cap.
Z cap. So you have angular momentum, and this angular momentum is actually your LZ, and this value is mr square theta dot Z cap. Okay. Now what will be torque? Torque is defined as what? dLZ upon dt.
Yes, sir.
होगा ना? Yes or no?
Yes, sir.
Yes. So let us try to take the derivative of this one. So देखते हैं हमें क्या मिलता है. यहां तक क्लियर है ये?
Yes, sir.
Okay. Okay, I can use this space. So if we are just calculating dLZ upon dt, and that value is m r dot theta dot 2 time is there plus m r square theta double dot. Is that it is correct expression?
Yes, sir.
And can I write this particular thing is R M R theta double dot plus, I can write R theta double dot plus 2 R dot theta dot. Can I write this thing?
Yes, sir.
Yes, sir.
And what is this particular thing?
A theta. A theta.
A theta. So your
Yeah.
torque is nothing but R, the value of torque is nothing but R M A theta. Yes. Now, when your torque is going to 0, then what will happen? When your torque is going to 0, is that R should be 0?
No, sir.
That will be very trivial. भाई R 0 हो जाएगा तो सभी खेल ही खत्म हो जाएगा, है ना? So R is not going to 0. So what M should be M will be 0?
No, sir.
No.
So which quantity have to be 0?
Tangential
Theta.
accelerator.
A theta. So if my torque is equal to 0, this implies A theta must be equal to 0, and this implies angular momentum must be constant. Yes?
Yes, sir.
And when your F theta, that means A theta is equal to 0. So if A theta is equal to 0, this implies F theta is equal to 0. Isn't it? From here? And if this type of situation will occur, it is identified as central force. क्या इसे कहेंगे? This is identified as what? Central force. The force will always acted towards the origin or away from origin. And if your angular momentum of a system is conserved, or and that is equivalent to your A theta is equal to 0, that is equivalent to your F theta is equal to 0, and that will tell you whether your force is central or not central force. Everyone comfortable?
Yes, sir.
Yes, sir.
Okay. And now what will be condition of circular orbit, or what will be condition of circular motion? यहाँ तक clear है?
हाँ सर.
Okay. So चलो देखते हैं. So circular motion. So there are two types of circular motion. The first circular motion is what? Uniform circular motion. So obviously, what is uniform circular motion?
Sir, where theta dot is constant.
Very good. Theta dot is omega, that is constant. Okay. So if uniform circle, and obviously radius, I can assume the radius of a circle is r naught. So that means r dot is equal to what? 0. And r double dot is also 0. So what is condition of circular orbit? So FR. What will happen to FR? बताइए FR क्या होगा? This will be 0, and this FR is actually M AR, and you can write M R double dot minus R theta dot square. You will put R is equal to R naught, R dot is equal to 0, R double dot is equal to 0, and theta dot is equal to omega. Your external force must be equal to M omega, minus sign is there, and that will be M omega square R. External force will be must be equal to centripetal force. Then your motion is what? Circular in nature. And what about F theta? What about F theta?
0.
0. F theta is 0. Isn't it? So if you are doing the uniform circular motion, that means your angular velocity, your angular momentum is conserved, isn't it?
Yes,
Because your if F theta is 0, that means the force is something like central. This is your uniform circular motion. And what about the non-uniform circular motion? This is uniform. What about non-uniform?
then F theta won't be 0, sir.
Hmm?
F theta won't be 0.
That means theta dot is some function of t, isn't it? That means theta double dot not equal to 0. So what will be your non-uniform circular motion? So you have AR. What will be your AR? AR will be,
So same, sir.
so you can write FR is equal to M AR. And what will be M? R double dot is 0 because you have radius R is equal to R naught. So R dot is equal to 0. So what you will get? You will again get minus M R omega as a function of t square. And in this case, is that F theta is also 0?
No, sir.
No. In this case, F theta is not going to 0. What will happen to F theta? Is that this term is going to 0? Yes, this term is going to 0. Why this term is going to 0?
Because
R dot is 0.
Because R is equal to R naught. So R dot is equal to 0. So your F theta is equal to M R. And what will be theta double dot? You can have omega dot. Isn't it? It may be function of time. Clear hai ye? And you can have FR and F theta. And what is your magnitude of force? Your magnitude of force is something FR square plus F theta square. Isn't it? This is your magnitude of force. So you have to be always careful when whether your motion is, if you are going for the circular motion, whether it is uniform circular or non-uniform circular. Okay, so this is the basic theory we have developed in a understanding of Newton's law in polar coordinate. Tomorrow we will try to solve different types of problems. So हमें किसका use करना होगा? Most of that. So you have to just remember mainly 3 formula. This is your R. R is nothing R cap. What is your velocity? Velocity is nothing R dot R cap plus R theta dot theta cap, and your acceleration is this one. Okay. So these 3 things we will try to use in a next class. So कल की class में हम लोग इसे finish करेंगे. Okay. So
Yes,
if
sir.
you have any doubt, you can just raise your doubt.
हाँ सर.
बताओ.
सर इसमें आपने बोला एक सेंट्रीफ्यूगल टर्म आता है. सर मैं सेंट्रीपिटल और सेंट्रीफ्यूगल में थोड़ा कंफ्यूज हो जाता हूँ.
सेंट्रीपिटल और सेंट्रीफ्यूगल में आपको कंफ्यूज होने की जरूरत नहीं है. When you will on the earth, okay,
Yes, sir.
and with respect to you, if something is rotating,
Yes, sir.
are you getting my point?
Yes, sir.
Then you will find the centripetal force. Okay.
Yes, sir.
And when suppose आप एक कार है, मैं इस तरह से ले रहा हूं, आप समझने की कोशिश करो. सपोज दिस इज अ सर्कुलर ट्रैक और ये एक कार है. ठीक है. अगर आप यहां से बैठकर इसे देख रहे हो, इस कार के अंदर एक बॉक्स है. ठीक है. तो बॉक्स के ऊपर आप, अगर आप यहां से देख रहे हो तो कार के ऊपर क्या लगेगा? सेंट्रीपिटल फोर्स है ना, बिकॉज यू आर एट द नॉन इनर्शियल फ्रेम.
Yes,
क्लियर
sir.
है?
Yes, sir.
बट अगर आप कार के अंदर बैठ जाओगे, then what will happen? You will at the non-inertial frame, you will get what? Centrifugal
Centrifugal
force.
force.
So
Okay, sir.
that is all about same उसी तरह की बात है. अगर आप जमीन पर बैठे हो तो ट्रेन उस डायरेक्शन में चलता हुआ नजर आ रहा है, और ट्रेन पर अगर आप बैठे हो तो जमीन अपोजिट डायरेक्शन में चलता हुआ नजर आएगा. Yes. So if you
Yes,
are
sir.
changing the frame, the magnitude will remain same, but direction is going to change.
Okay, sir.
ठीक है.
Yes, sir. And इस एक्सप्रेशन में हम लोग को सेंट्रीपिटल फोर्स मिलता है, राइट?
ये जो इक्वेशन लिख रहे हैं, वी आर राइटिंग फ्रॉम द लेबोरेटरी फ्रेम ऑफ रेफरेंस. वी आर नॉट राइटिंग फ्रॉम द पॉइंट ऑफ व्यू रोटेशनल फ्रेम ऑफ रेफरेंस.
Yes, sir.
ठीक है.
Yes, sir.
व्हेन वी विल राइट इट फ्रॉम द रोटेशनल फ्रेम ऑफ रेफरेंस, यू कैन इजिली, आपके पास सेंट्रीफ्यूगल फोर्स का एक्सप्रेशन आ जाएगा, जो कि हम वेक्टर के थ्रू लिख सकते हैं. ठीक है, ठीक है।
Yes, sir. Yes, sir. Yes, sir.
So it means it is a pseudo force, centripetal, a centrifugal.
Obviously, whenever you are on the non-inertial frame, it is pseudo force. Okay.
Okay, sir.
Whenever you are at the non-inertial frame, what is pseudo force? Pseudo force is a one type of magical force which can be used to apply the Newton's law of motion even in non-inertial frame.
Yes, sir. For making calculation.
That is for the
suitable.
making calculation. मैंने आपको न्यूटन्स लॉ जब पढ़ाया था तो उसमें मैंने आपको डिस्कस किया था, है ना?
Yes, sir. Yes, sir.
Unless until you don't have cause, there is not any effect.
Yes, sir. Yes, sir.
Are you getting my point? So यहाँ पर effect तो दिख रहा है, लेकिन cause को लेने के लिए हमें एक extra force को लेना पड़ता है. That is basically what? Centrifugal force.
Yes, sir.
ठीक
Thank
है?
you, sir.
Okay. So in one lecture we will also discuss the rotational frame of reference, but उसका अभी यहाँ पर कोई भी रोल नहीं है. इसी कारण मैंने यहाँ Coriolis force का भी यूज नहीं किया है, बाकी चीजों का भी यूज नहीं किया है. We will discuss that thing in a rotational frame of reference. ठीक है?
Yes, sir.
Okay. This is just from the laboratory frame. अब मैं origin पर बैठा हूं और सारा चीज को देख रहा हूं. Are you getting my point? So this
हाँ,
is the
sir.
thing. और कल हम लोग प्रॉब्लम सॉल्व करेंगे, then you will find each and everything can be easily solved. Okay.
Yes, sir.
Now just go for and calculate the torque as F cross R. जरा इसे कैलकुलेट करो एज अ होमवर्क. सो F में कितने पार्ट है?
2 part.
2 पार्ट है ना? एंड जस्ट ट्राई टू कैलकुलेट व्हाट विल बी टॉर्क. ठीक है?
Okay, sir.
Okay, just try to calculate what will be the value of torque. So tomorrow we will just try to solve different types of problem. Okay, ठीक है? Thank you. Good night.
Thank you, sir.
Thank you, sir.
Thank you, sir.